Yo, 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 yo. Hey, everybody. Hope you're all doing well. This is Mr. G. We're going to talk about theoretical probability of compound events. Okay. So a compound event is when it's just not one thing that's happening, it's multiple things that are happening, or two different things, or two or more things are happening. So, let's get to it. So Jacob rolls two fair number cubes. Remember, fair number cubes are a normal dice that has 6 sides. We want to find the probability that the sum of the numbers he rolls is 8. So here I have a table. We're going to fill out this table together. This first top part of the table represents dice number 1, the first die. The second part over here is the second dice because we have 2 different dice, so there's 2 different numbers that we can roll. We can roll 2 1s, we can roll 1 and a 2, so on and so forth. So this table shows all the possible sums that I can get when rolling 2 dice. So if the first die is a 1, the second one's a 1, the sum of these 2 numbers is a 2. Okay, because when you roll 2 dice, you roll 2 1s, you actually are rolling a 2. If the first die is a 2 and the second dice is still a 1, that would be a 3. 3 and 1 would make a 4. 4 and 1 would make a 5. 5 and 1 would make a 6. And 6 and 1 would make a 7. So what we're doing is because we're rolling 2 dice, what this does, what we need to do is we need to figure out all the possible outcomes. This table is actually giving us a list of all of the possible outcomes we have when rolling 2 dice. So I can roll a 2, 3, 4, 5, or 6. Now, let's say the first die was a 1, the second die was a 2, I'm rolling a 3. I know that these are 2 different ways of making a 3. I can roll the first die is a 1, the second dice is a 2, the first dice is a 2, the second one's a 1, that adds up to 3. But if the first one's a 1 and the second one's a 2, it still adds up to 3. These are different possible outcomes, even though they result in the same number because they resulted from the different dice showing up different values. So, let's continue this on. 2 and 2 makes 4. 2 and 3 makes 5. 2 and 4 makes 6, 7, and 8. We're going to notice a pattern here soon. Now, if I have a 1 and a 3, that makes a sum of 4. 2 and 3 makes a 5. 3 and 3 makes a 6. 3 and 4 makes a 7. 3 and 5 makes an 8, and then I get a 9. And if we notice the pattern here, we're just counting up each time for the sums. 5 and 1 makes a 6. That's 7, 8, 9, 10, 11. And 6 and 1 makes 7. 8, 9, 10, 11, 12. So these are all the possible sums when I roll 2 dice. What I just did is I just made a table that shows me all of my possible outcomes. There is one possible way I could ever roll a 2. There are 2 possible ways for me to roll a 3 when I roll 2 dice. There are 3 possible ways to roll a 4. 4 possible ways to roll a 5. 5 possible ways to roll a 6. 6 possible ways to roll a 7. And if we notice 7 is the number that shows up the most. So that means that when you roll a dice, the probability of rolling a 7 is greater than anything else when you're rolling 2 dice. And then we go back down, 5 possibilities for 8, 4 possibilities of 9, 3 possibilities of 10, 2 for 11, and 1 for 12. So if I want to find the probability that the sum of the numbers is 8, what I need to figure out is how many total possible outcomes are there. This is a list of all my total possible outcomes. There are 36 possible outcomes here. 6 times 6 is 36. So when you roll 2 dice, there's actually 36 possible outcomes. Now I want to figure out how many of those are 8s. Well, I've got 1, 2, 3, 4, 5. So there's 5 possible combinations of the 2 dice to make an 8. So therefore there are 5 out of 36 chances to roll an 8. That's the probability of rolling an 8 when we roll 2 dice, not just 1. So the reason why this is compound events, I'm rolling more than 1 die now. I'm only rolling more than 1 number cube. I'm now rolling 2. Now, if it asks me to give an example of an event that is more likely than rolling a sum of 8. So what's going to be more likely than rolling a sum of 8? 8's a pretty, I mean, there's five possibilities out of 36 for 8. If I look at 9, there's only 4, 10, there's only 3, 11's 2, 12, 1. If I go to 6's, that's 5. That's equally likely to happen. So the only one that's more likely to happen would be the probability of rolling a 7. Now I could say the probability of rolling a number that's greater than 8 would also be an example there. Because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible ways of rolling a number that's larger than 8. You can say less than 8. There's a lot of possible answers here. But the single number, the only one that's more likely to happen than rolling an 8 is a 7. So 36 possible outcomes with 2 dice. One way we can figure it out is for the first dice, there's 6 possible outcomes. For the second dice, there's 6 possible outcomes. 6 times 6 is 36. Okay. So another way to list all of my possible outcomes is by doing a tree diagram. Okay. So we're going to do a tree diagram with this deli. A deli prepares sandwiches with one type of bread. So you have the choice of white or wheat. So I'm going to start off my tree diagram at that. My first choice, first decision I have to make is I can have white bread or I can have wheat bread. And then you also get one type of meat. So my second choice that I have to make is the type of meat. I can have ham, turkey, or chicken. So I have 3 possible combinations on white bread. I could have white bread with ham. I could have white bread with turkey. Or I could have white bread with chicken. I also have those same 3 possible combinations with wheat. I could have wheat bread with ham, wheat bread with turkey, wheat bread with chicken. Finally, my third possible choice is the type of cheese. I could have cheddar or Swiss. We'll change the color here. So that means I could have a white bread sandwich. That's a ham sandwich, but I could have 2 possible types of cheese from ham. So I'm going to do trees to break off from my 2 types of cheese. I could have Swiss or cheddar. And those same 2 possibilities are also going to happen with turkey. I could have Swiss or cheddar. And the same 2 possible cheese options are also available with chicken. Swiss or cheddar. I'm just using S and C. Same thing here. My ham sandwich could have Swiss or cheddar, but this one had wheat bread. Wheat and turkey could also have Swiss and cheddar. And then wheat and chicken could also have Swiss and cheddar. So if I look here, if I follow this tree, if I say these are all the possible combinations that I have. I could have white bread with ham and Swiss. That's one type of sandwich. I could also have white bread with ham with cheddar. I could have white with turkey with Swiss, or I could have white with turkey with cheddar. I could have white with chicken with Swiss, white with chicken with cheddar. And then all the same things go, but now with wheat bread. Those are all my possible combinations. Now, if we look here, so for all the possible combinations, if I count my last row of my tree, that tells me how many possible combinations I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are a total of 12 possible combinations when making a sandwich. If I want to know what is the probability then of making a sandwich, picking a sandwich at random and getting turkey and Swiss on wheat bread. So that would be wheat bread, turkey, Swiss cheese. That is this sandwich right here. Wheat bread, turkey, Swiss. That is 1 out of 12 to randomly select that sandwich. So there's 12 possible combinations. Now another way I know there's 12 possible combinations. For my first choice, there's 2 options, right? White and wheat. For my second choice, there's 3 options. Ham, turkey, and chicken. And for my cheese, there is 2 options. 2 times 3 is 6. 6 times 2 is 12. But the tree diagram is nice because it shows me how many possible combinations I have depending on what I ask. So what is the probability of picking a ham sandwich? So again, I know my denominator is 12. But for ham sandwiches, I have, let's do this in a different color. I'll do this one in blue. I could have ham and Swiss, ham and cheddar on wheat. I could also have ham and Swiss, ham and cheddar on white. So that's 4 possible sandwiches. That'd be 4 out of 12, which is 1/3. So we're listing all of our possible outcomes by either doing a tree diagram. This one we did it by making a table. And then we use that tree diagram to figure out the probability and how many total possible outcomes there are. That's it. Okay. So, for total possible outcomes, this is your things to remember. Multiply the total possible outcomes for each individual event. So here's what I mean by that. Going back to our 2 dice. This is, if I just rolled 1 dice, that'd be a simple event. It's just one thing happening. So the total possible outcomes for rolling 1 die is 6 possible outcomes. Well, if we're rolling a second dice, again, that second dice, there's still only 6 possible outcomes for that second individual die if it was its own thing. So 6 possible outcomes, 6 possible outcomes, 6 times 6 is 36. For individual possible outcomes, if I was picking just bread, there's 2 possible outcomes, right? So there's 2. If I was picking just meat, there's 3 possible outcomes. If I was picking just cheese, there's 2. So this would be the total possible outcomes for just this simple event. 3 possible outcomes for just this one single event. 2 possible outcomes for just this one event. 2 times 3 times 2 is 12. So that's one way to get you your total possible outcomes. Okay. Here's an example. See how you do. Try it out. And let me know if you guys have any questions. That's it. Gordias out.